and do this one for extra practice. So this is exactly like the one we just did. We're going to write the equation of a circle, and I'm going to stop right there and remind us, what does the equation of a circle look like? It's got a parentheses squared with an x in it, right? Mm-hmm. Plus a parentheses squared with a y in it, and then it equals something. Remember that from 30 minutes ago? Okay, so to write the equation of the circle, we need the center and the radius. Because remember, the center is going to help us fill in the parentheses, and the radius is going to give us this. So what we have are the endpoints of a diameter. The endpoints of a diameter. So 5, -6, and 1, 4. Okay, so Quinn, can you remember anything about how to do this? Where to start, what we might want to do?
Isn't that x plus 5 and we get the square from that, and then plus y minus 6.
Okay, you're really close because you're going to put an x number in here and a y number in here, but it isn't the endpoints that go in there. What goes in here are the coordinates of the
midpoint,
the center, which is the midpoint. So here, that's the x and the y, Quinn, that you're going to stick in the parentheses. Like you did this one, only you're going to stick in that one. How do we find the midpoint?
You
Average. So 5 and 1 makes 6. Divided by 2 is 3. How do we find midpoint? We average. So 5 plus 1 divided by 2. All right, -6 plus 4, -2, divided by 2, -1. Please don't forget to divide by 2. When you do an average, you add and divide by 2. Okay, so then Quinn, come over here, and the 3's going to go in here, and the -1's going to go in here. But remember, when we put them in the parentheses, we do the opposite. So this is going to be x minus 3, and this is going to be y plus 1. So the center, the midpoint, is what goes in the parentheses, opposite. Everybody still on board here? Okay, now I need my radius. Would you agree that this would be a radius?
Yeah.
yes.
So I have to figure out how long that is. In other words, I need to know what the distance is from here to here.
Mm-hmm.
So to do that, I'll do my distance formula. How does that work? Who remembers?
It's gonna be x minus, or yeah, x minus, like, okay, wait a minute. It'd be like 3 minus 1.
So it's your x minus your x squared.
Yeah.
And then your y minus your y squared. And then we're going to add those together, right? Here we go. 3 minus 1 is 2. Squared is 4. -1 minus 4, be careful, -1 plus -4, -5, squared, 25. So your radius is the square root of 29. This will catch you if you're not careful. When you write the equation of a circle, if the radius is 10, then your equation equals 100, right?
Yeah.
If the radius is 5, then your equation equals 25. So in other words, to write your equation, you have to take your radius and square it. What happens when you square the square root of 29?
It's just 29.
It's just 29. So that's what goes there. Okay? All right, that was an extra because I thought maybe we needed a little more practice with that. All right, so now we've got our absolute value work. Okay, here we go. Don't make these harder than they are. You should be able to figure these out. What do you remember about absolute value? Jacob?
Absolute value is how far away it is from 0.
Very good. That is the definition. Very, very good. How far? So if you have a number line, the absolute value of a number is how far it is from 0. And because it's a distance, it will always be positive, right? So to find this absolute value, we're going to do the parentheses first. Mrs. Ford, those aren't parentheses. No, they aren't, but treat them like parentheses. Do what's in them first. Okay, so what's -3 plus 2? -1. And since it's an absolute value, it will become positive. Please, do not do the individual pieces first. You do the work inside first, and then you take the absolute value. All right, so here we go, same thing. What's this?
-3.
-3. And the absolute value of -3 is? 3. What's this? 4. And the absolute value of 4 is? 4. And now you're going to subtract those two. 3 minus 4.
-1.
So the answer is -1. We do each absolute value independently, separately, and then we're going to subtract it. All right. How about this one? 5 minus 5. Hopefully you got 0. Because the absolute value of -5 is 5. So we're doing 5 minus 5. Remember, absolute value makes every negative positive. All right, last one. 10 minus 3.
7.
Absolute value of 7 is? 7. 3 minus 10.
-7.
It's -7, and the absolute value of that is also 7. And we're adding them this time, so our answer is 14. Now, I think every single one of you can do these problems. Slow down, one step at a time. You can do these. They're easy. Do the inside of the absolute value first, and then make it positive. Well, are you ready for some joyous good news? P2 is due on Wednesday. P2 is due on Wednesday, so if you're getting super excited, you can get them both done tonight. Get them turned in. Or turn it in now, whatever. P2, you'll do it, rip it off, and put it in the plate by Wednesday at the end of the day.
And part 1 is due tomorrow.
Part 1 is due tomorrow. And nobody came for office hours this morning. I mean, none of you came this morning. On Wednesday, if you have trouble with the problem, come in Wednesday morning and get it figured out. All right, so now we're ready for P3. And we want to know, is -2 a solution of this equation? Well, there are a couple of ways you can go about this. Who has an idea? How could you tell, like you're not checking an answer, how could you tell if -2 is an answer? Alex?
Would you plug in -2 for the x's?
That'll work, because if it's a solution to this equation, doesn't that mean you should be able to plug it in and get 0? Yeah, so here we go, I'm gonna plug in -2. Be careful when you plug it in. Notice, I plugged in -2 for my x's, but I had my negative in parentheses. So this is the number -2 squared, and this is -4 times the number -2. All right, let's see if that works. What's the sequel?
4.
Positive 4. -2 times -2, so that's positive 4. Watch it, what does this equal? Positive 8. Does that work? Did it check out like it was supposed to?
Yes.
Yes, it does. So one way to show that something is indeed an answer, a solution, is to just plug it in and check. Does anybody have another thought on that? Olivia?
You could factor the equation.
She says we could go back to the original equation and actually solve it and see if we get -2 as one of our answers. And she says to solve this, she would factor it. Now I know some of you hate doing this. Some of you hate factoring. I don't know what to say. It's a fact of our life. We have to factor. So anyhow, if you want to do it this way, you don't have to do it this way. But she says, I'm going to factor. So I need factors of 12 that would add up to 4. What would be a couple factors of 12? 6 and 2. And I need -6 and +2. So when I FOIL that out, I get x squared plus 2x minus 6x minus 12. FOIL first, outside, inside last. Okay, that's my check. So what does that mean my answers are? If I factored into x minus 6, then x equals 6, and x equals -2. Two things about that. First of all, did we get the answer we were checking? Yep, so this would be another way to do it. This is perfectly fine. If you like this way, do it this way. But this would be another option. Second thing I want you to notice though, ties back into our circles. Because when the parentheses was x minus 6, what was your actual x value? 6. Remember when we were doing our centers? When we put them into the parentheses, we had to make them the opposite. This is exactly the same idea. Exactly the same idea. Wonderful, wonderful, wonderful. All right, anybody have an issue with that? Okay, now we're going to talk about linear equations. You got to hang on for about 10 more minutes, folks, okay? Stay with me. I know you have a full tummy and you just want to take a nap. Do it next period. I need you to stay awake. We're going to talk about whether these things are linear equations or not. Now, does anybody have a gut feeling about any of them? Yes or no? I mean, do you see one that you think is, or do you see one that you think isn't? Any of these? To be a linear equation, you graph as a line. That's what it means, you're gonna graph as a line. Now, there are some rules about linear equations. This one is not a linear equation, so I'm gonna write no. And it's not a linear equation because can't have x under a radical. If you are going to be linear, you will not have an x under the radical. If you graphed that, it would not be a line, it would be like an arc. Okay? Linear means you graph as a line. It'll never happen if x is under a radical. So that's our first rule, x can't be under a radical. All right, so I don't see any more of those. This one, right here, is not linear because x can't be in the denominator. You can't have x under a radical, and you can't have it in the denominator. So far we have two rules. There's another one, but we have two so far. Can't be under x, can't be under radical, x can't be in the denominator. Okay? Now, that kind of rules out this one. Would you agree? Okay, so this is a no. X can't be in denominator. Now, this one isn't linear either. This one's a no. Does anybody want to take a wild guess why? What's wrong with it? Declan?
Is it because there's x on both sides?
No, you can have an x on both sides. What you can't have is,
There's an exponent?
yeah, can't have an exponent. X can't have exponent. Now, when I say it can't have an exponent, obviously it can have a 1 as an exponent. So I'll say it can't have an exponent other than 1. X to the first. These are yeses. These do not violate any rules.